All right, this is AP Calculus. These are the solutions to worksheet 8-1, so this is the key. All right, so we have a function here, and it's number of people entering, so it's a positive rate. It doesn't really matter, but just force of habit, it's a positive rate. Let's go ahead and enter in this equation. We have 1380 x squared minus 675 x cubed. Interesting. Cubed is going to be, I'm just going to do power of 3 like that. And that's all I have. I do have a window between 0 and 2. I don't know if I'll need that, but I'll hit window 0, enter, 2, enter, and then a second mode to quit out of that. Okay, so I have it programmed in for y1. Rate at which people enter the auditorium at t is equal to 1. So that's just going to be one of those math, or you don't even hit math. You just do y1 of 1. So r of 1 is equal to, and I do var is right, enter, enter, y1 of 1 is equal to 705. So come back over here, this is 705, and indicate units, this is the rate at which. So if it's a rate, then it's going to be people per per hour. Oh, it even tells it. RT is measured in people per hour, so that's really nice for us. All right. B, what is the, or is the rate of people increasing or decreasing? So again, if you ever see the words increasing or decreasing, take the derivative of the rate. Well, this is the rate, so I'm really asking what is r prime at this time 1. So over here I do math 8, the derivative of var is right, enter 1 of y1 with respect to x at 1. And I get 734.999. I think I can round up here to 735. Oh, actually, I don't care, because I only care if it's increasing or decreasing. Is this number positive or negative? So I'll go ahead and write down 735 is equal to 735, which happens to be greater than 0, and therefore I can go ahead and type in here. Increasing, ooh, that's a bit big for my font. Let's come down here to size 12. Increasing because r prime of 1, Mr. Sindel, is greater than 0. Perfect. The number of gallons is P, and that's entering the lake. No, it changes at a rate, so we don't know if it's entering or leaving, but that's the rate that it's in, the rate of pollutant in the pond or lake. Find the rate at which it's changing at 9. So I'm just looking for what is P prime in this case of 9. I'm just plugging into my formula. So again, I need to come over here and enter my formula. 1, I guess I should clear out of this. 1 minus 3, and it's going to be second natural log to get to the e to the power of, that's a negative, it's hard to see there, but it's a negative 0.2 square root, so second squared of t. And I don't have to end my parentheses, it knows what I'm talking about. Let's get out of that. I'm doing var is right, enter, enter, y1 of 9. Oh, I have to put my parentheses of 9. And I got negative 0.646. So that's equal to negative 0.646, indicate units, gallons per day in this case. So it's going to be gallons. I need to write a little bit neater. Maybe we can zoom in to make it look better. Gallons per day. All right. Is the rate of pollutant increasing or decreasing? So it's rate, and then an increasing and decreasing, the derivative of the rate. So it's really talking about P prime prime in this case, because P prime is the rate, and then increasing and decreasing is P prime prime at 9. I want to know if it's positive or negative. Again, that's going to be that math 8 guy, the derivative of my var is right, enter, enter, my y1 function with respect to x at 9. Is that a positive or a negative answer? That's a positive answer. It's 0.055, I guess, 0.055, equal to 0.055, which is positive. So I come down here and I type in my answer. I say it is increasing because P prime prime of 9 is greater than 0. Part C, is the amount of pollutant in the lake increasing at times equal to 9? So it's talking about an amount now. So it's just talking, amount is just P, because P prime was the rate. So is that amount, I'll leave that there, increasing? So take the derivative. Take the derivative of p. It's really asking about p prime of 9, which we found up here. P prime of 9 is negative 6.46, or negative 0.646, equals negative 0.646. And is that increasing or decreasing? Well, that's less than 0. So typing in our answer down here, we say it is not increasing. So it's asking if it's increasing. You can say it's decreasing, or you can say it is not increasing, or you can say decreasing. And why? Because p prime of 9 is less than 0. It's a negative answer. All right, next question. Let's zoom out a little bit here. We are talking about number of cars. So let's go ahead and enter in our equation into our y equals. Let's clear out of that. It's going to be 60 second square root of t. I do need to end my parentheses now because I'm now going to be multiplying that by sine squared. So to do sine squared, I'm going to do sine of t over 3 first and then square it afterwards. That's how you do it for the calculator. So t divided by 3, and then I have to do that squared. All right, so I have that entered correctly. Okay, let's get out of that. We have a window from 0 to 18. If I wanted to graph that, I could come over here and say, yeah, 0, enter, 18, enter, and graph it, but it's faster to not graph it. So A is asking, what is the rate at which cars turn left? And this is cars turn left. So that is the correct left function. So it's a rate, and this is already given to us as a rate. So it's just telling us plug in 7 into your function. So what is L of 7? And we do that by just doing var is right, enter, enter, y1 of 7. And that's 83.000, and I'm just going to say that's 83. 83. Indicate units. It's a rate of cars. So it's cars per hour. So let's write out cars per hour. All right. Next, are cars turning left at an increasing or decreasing rate? So turning left is not a rate. This is like the antiderivative of L. That's what it's talking about. And then increasing or decreasing, now it's talking about L, because I take the derivative of the integral. So now I'm talking about at L of 7, is that positive or negative? Well, that's equal to 83 again. And again, if you're not watching the video, this is going to look weird for the notes, but L of 7 is greater than 0, and we can come down here and type in our answer now. We can say that decreasing because L of 7 is greater than 0. And yeah, all right, that's that. We're on to the backside. Sandy Point Beach. Ooh, this guy looks very familiar. It reminds me of a pretest or something. I wonder if that's going to come up again. We'll see. It's definitely from an AP test. We have a function that is removing sand. So if I see removes, that means it's a negative rate here. And pumping sand, so if I'm giving you sand, that's going to be a positive rate. So let's program both of these on our calculator immediately, knowing what they are. So my y equals, let's clear out of that. It's going to be 2 plus 5 sine of 4 second pi t divided by 25. Again, you don't need to have any special parentheses. I don't even need to have that parenthesis. I can delete that if I wanted to. And my y2 is 15t divided by, and then I do need parentheses here because this is the quantity of 1 plus 3t, or x in this case. And immediately turn it into one function. My y3 is going to be the positive minus the negative. My positive is the second equation in this case, so I'm going to do y2 minus y1. It's always positive minus negative. So var is right, enter 2 minus var is right, enter 1. My y2 minus my y1. All right, now I have all my functions ready to go. Find the rate at which sand is being removed. I'm asking about the negative rate. So it's asking here, what is r of 4 in this case? R of 4. And the way that I do that, this is my y1 function. So I'm going to come back here and do, let's get rid of this. Var is right, enter, enter my y1 of 4. And I get 6.524 equals 6.524. And indicate units. So does it say what our units is? Have units of cubic yards per hour. So yards is yd, and cubed means to the power of 3. So cubic yards is really yd to the power of 3, and then per hour is just hr, of course, so it's going to be yards cubed per hour. And if you don't like writing that out, you can write out the words cubic yards per hour, and you'll still get the right units for the point there, but that's a quicker way of writing it. And I'm noticing that this 3 doesn't look like it's a power of. Let me make that to a power of 3, a little bit better. Find the rate at which sand is being added. Well, added is S, because the pumping is adding sand. So I'm doing S of 4. So that's my y2 function again, this function right there. So it's going to be vars right, enter 2, my y2 of 4 again. And when I do that, I get 4.615. 4.615, same units, yards cubed per hour. All right, to find the rate at which the total amount of sand, the entire thing is happening at time is equal to 4. Well, I could just do my positive rate minus my negative rate. You'll notice that my negative rate is bigger than my positive rate, so I should have a negative answer. So I can say that my S of 4, that's an S, not a 5. My S of 4 minus my R of 4, which is programmed into my y3 function. I can just come over here and do vars right, enter 3. My y3 of 4, that's a 3, y3 of 4 is equal to negative 1.909. Negative 1.909. Again, indicate units. It's still yards cubed per hour because it's still the rate. All right. Moving on to part D, and I guess I should be checking my answers on my old solution guide. 6.524, 4.615, 1.909. My handwriting was bad. And finally, D, is the amount of sand of the beach increasing or decreasing at time is equal to 4? Well, it's talking about this answer right here. So amount of sand is just not a rate. Again, both of these were rates, so I'm kind of thinking of the integral of S of 4 minus R of 4. And then is it increasing or decreasing? So take the derivative, so d dt of that guy, and then those kind of cancel out. So I'm just asking about what is S of 4 minus R of 4? What is the rate? Is it positive or negative at time is equal to 4? Is this number right here positive or negative? So a long-winded way of saying, let's come all the way back here. I don't even need to write anything aside from it's decreasing. Decreasing because we can say S of 4 minus R of 4 is less than 0. Perfect. And we're talking about snow in Janet's driveway, and we have that function. Let's go ahead and plug that bad boy into our calculator. So y equals, let's get rid of all of those. My y1 is going to be, okay, so is this the positive? Yeah, accumulates. Accumulates is a positive word. I'm getting bigger and bigger, so this is a positive rate function. And Janet is removing snow. So these are all negative rates, and there's 3 of them. And notice that they're all kind of, they're constant functions. I'm not removing snow. I'm removing snow kind of fast. Now I'm getting tired and I'm removing snow. I'm still removing snow, but not as fast as I was between 6 and 7. So I do need to program this one, and that's going to be a little bit harder. It's going to be 7x second natural log e to the power of cosine of t. Okay, so I have that function programmed in. Find the rate at which Janet removes snow at time is equal to 8. Well, remove snow, that's the negative rate. So it's talking about my negative rate, my piecewise function. At time is equal to 8. Well, where's 8? 8 isn't there. It's not there. Ah, there's 8. 8 is between 7 and 9, so it's just asking, it's 108. So we say G of 8 is equal to 108. And indicate units here. Our units, let's see, cubic feet per hour. Again, feet cubed per hour. So rewrite that, feet cubed per hour. Find the rate at which the snow accumulates. So now I'm doing the positive function, this function up here, so that's going to be f of 8. And I come back over here, let's clear out of all this. Clear, vars right, enter 1 of 8. And I get 48.417. 48.417, and that's still in, oh, that's a bad F. Ft, feet cubed per hour. Now find the rate at which the total amount of snow on the driveway is changing at t is equal to 8. Well, that's going to be subtracting the two. And there is a way to do that on a calculator, but it's pretty easy. I just have to subtract one another. So I say, well, the positive amount of snow, so f of 8, and then I subtract the 108, so minus g of 8. That's what I'm looking for, the total amount of snow. And I have that number in my calculator still, so I can say just minus 108. If you're scared of doing math, like I sometimes am. Negative 59.583. Negative 59.583, and that's still in feet cubed per minute. And now I'm kind of wondering about my units here. Should this be a negative? Should it be a positive? Well, since it's the rate at which it's being removed, you kind of assume that it's 108 being removed. If it said snow being added, then you'd say, oh, negative 108 is being added. But since it's talking about removed, it's still at positive 108 being removed per hour. Same thing with this one. That one's clearly positive. But this one should be a negative answer just because it's the rate at which the total amount of snow is changing. So we actually care about direction, and we do need a negative amount. Is the amount of snow on the driveway increasing or decreasing at time is equal to 8? So again, you have to think about just amount of snow, no longer a rate. So kind of like the integral of this guy, and then you take the derivative, because whenever it says increasing or decreasing, you take the derivative of what it was talking about. So this is the integral, then the derivative of the integral is just purely talking about what is the sign of this thing. Oh, the sign was negative, so we're going to come back down here and we're going to say, well, it's negative, so it's a decreasing. Decreasing at t is equal to 8, and then because we can say f of 8 minus, we'll do space, g of 8 is less than 0 is a negative answer. Cool, and that concludes worksheet 8-1.